All right. No, but I do. I am like using a few different colors, though. Okay. All right. Here's the problem that we're working with. I know. It's been doing that today. What is the kinetic energy of a bicycle with a mass of 14 kilograms traveling at a speed of 3 meters per second? Okay, so in your space right here, we're gonna work 1, 2, 3 problems. I want you to keep enough space so that, like, see, we're gonna draw like a line right here. We're gonna put another one and another one. Okay, so calculate this. Okay, so what was our mass? And what was our velocity? And then we got to carry over the little squared. What is 3 squared? 3 times 3. What do we get? 63 what? Joules. Okay? Now, let's say that this mass right here gets doubled. You have a question on something else? 3 squared is 3 times 3. You put 6? Okay. Everybody ready? Okay. Let's say this mass right here gets doubled. What would the new mass be? Okay, 28 kilograms. So notice I'm using a different color, okay? Over here, I want to rework it with the new mass. Tell me what you get. What'd you get? 126 joules? That is correct. Who didn't get that? Everybody understand how to get that? Okay, so we went from 63 joules to 126. There's going to be a pattern here. Okay, y'all should notice that there's a pattern here. What? It's not multiplied by 22. 63 times 2 is 126. We doubled the mass. And so what happened to the kinetic energy? It doubled. So what do you think, what if we double the mass again? What do we think our kinetic energy would be? Let's see. So let's say our mass is 56 kilograms. Who's lost and you don't see what we're doing? Because on the LEAP test, they could just give you this in a data table and say, okay, what would the number be at the 5th step of doubling it? You know, like after you've doubled it, like you know, keep going to, you see what I'm saying? And they would ask you to predict that. It is 252 joules. 0.5 times 56 times 9. Okay, so, what? There is a relationship here, okay? This is what you've got to memorize. Like for my test, for the LEAP test, this is what's the most important right here. Kinetic energy and mass have a directly proportional relationship. Directly proportional. What does that mean? If the mass changes, then the whole thing will change. The relationship is between kinetic energy and mass. So if the mass changes, what happens to the kinetic energy? It changes the same as the mass, whatever it is. So let's say we double the mass. What does that do? Doubles kinetic energy. What if we triple it? Triple mass, triple kinetic energy. Those little lines mean the word comes down. Okay? So, not only do they want y'all to know this, like in words, they want you to show that on a graph. How would a graph show that? If kinetic energy goes up by 1, mass goes up by 1. 1, 1, 1, 1. I taught you what that's going to look like. What if it's 2, 2, 2, 2, 2, 2? So if this is our graph, this is kinetic energy, this is mass, what should my line look like? Boom, straight going up. I know y'all remember that. I taught y'all that. Remember, it's like it increases the same amount every time. Like that would be 1, 1, 2, 2, 3, 3. That's the easy one. That's not hard at all. You can memorize that. They increase the same amount, or by the same amount. Does that make sense? Okay. Speed's the harder one. So look. I want to use the same problem, so just rewrite it. And then we figured out the kinetic energy at 3 meters per second. We can copy that. My camera's acting up today. So now we're going to mess with the speed. Is the same thing going to happen? I don't know. What would our speed be if we double it? Okay, so now let's double this speed and get that energy. No, it's not 84 joules. Did you do 6 times 6? What's 6 times 6? That's usually where everybody is messing up on me. .5 times 14 times 36. Put in 0.5 times 14 times 36. $252. So we went from 63 to 252. That's a big jump, huh? At the top, look, we only went from 63 to 126. Now we went from 63 to 252. Is it?
Yeah. The third time we doubled it, it's the same answer.
It is the same answer. So that means double, double. It quadruples. So let's say, okay, what would our speed be if we double it again? 6 times 2. 12. So, what do you think the kinetic energy is going to be for 12? Use your calculator. Y'all just figured it out. Y'all are smart. No. 1008. You'd have to do, y'all just told me that from 63 to 252, it went up 4 times. So if you had to take 63 and multiply it by 4 to get that, so what are you going to do with this? Multiply it by 4? Okay, let's see if it checks out. Kinetic energy equals 1/2 mv squared. The mass is still 14, but now we're going 12. So what's 12 times 12? What? 0.5 times 14 times 144. What would the next amount be? 4,032. You just multiply. Yes. Okay, here's the rule. Okay? Kinetic energy and speed have an exponential relationship. Like exponent, but IAL. It's not bad. I was just afraid of how I was going to teach it to y'all, but like, when I broke it down like this, I knew that this was the easiest way to do it. Well, if I wouldn't have taught it like this, it would have been a lot harder. So, what does an exponential relationship actually mean? This is what it means. Kinetic energy increases by the square of the speed. That's what you got to know. It increases by the square of the speed. So let's say speed is going up by 2. What's 2 squared? So that's where y'all's quadruple came from. See what I'm saying? Okay, if speed's going up by 3, 3 squared, 9.
I don't know how to say that, so.
Yeah, I know, but do you get it? Like, so we would be multiplying times 9 to get the kinetic energy. 4.
Miss Brown to the office. Miss Brown to the office.
Oh, yeah.
That's why I've been crazy with y'all about what is 25 times 2? 50. But what's 25 squared? You see what I'm saying? That's why
So like
5 would equal 25. Yes.
Okay.
Okay, and it just keeps on going. So this, okay, here I'm going to be honest with you. This is probably something they would put in a data table and then put this and then say, oh, what's that?
Joy.
Okay? Y'all got it. You can do that. Okay? Now, let me show you. If we graph it, that's what it looks like. Because think about it. These are our numbers from earlier. 63, 252, 1008. It jumps so much that we're getting that curve. Look, it goes from 1008 to 4000 whatever. 4032. You see what I'm saying? So we get a curve line. So on your note page, put kinetic energy and speed and draw that curve. Okay? Huh? You speed around the curve, yeah. That's a good way to remember it. Okay, so for my test, I need you to know the graph, and I need you to know the word. Like this one increases by the square of the speed. This one, if this doubles, it doubles. Triples, triples. You need to know that, okay? That's not hard. You'll have to work some problems on the test, but geez, we've worked so many by now. Can you not do?